Welcome friends. In our previous session, we were discussing about that how to start the issue related to capacity allocation. We took a very simple case of two class that there is a server where we have a capacity known as capital C. We have discounted fare category, we have full fare category, and how to decide the booking limit for discounted fare, and based on that the protection level for full fare case was also decided. We discussed the equation y equals to C minus B for protection label under 2 class, where you remember that capital C is our total capacity and B is our booking limit. We also discussed the use of decision tree approach for determining the B, so that we can minimize the issues of spoilage and dilution. And then we finally discussed about Littlewood rule, so that we saw that it is very convenient for us to decide this booking label with the ratio of discounted fare and full fare. So, basically PD and PF, discounted fare and full fare, that become a kind of a key for deciding the booking limits. And we discussed that two extreme cases. In one case PD is equals to 0, and in another extreme case PD is equals to PF, or you can say in another word ratio is 0 or ratio is 1. So, these are the two extreme cases, and whenever these two extreme cases are happening, you are going to have no classes, the entire server is just a single class. If it is PD equals to 0, then you say theoretically you will say that entire system is given the full fare seats, and if PD is equals to PF, then you say that entire system is given only the discounted fare seats. When there is only one class, it is meaningless to say whether it is a discounted fare or full fare, it is only one fare which is there. And in that we realize that using this PD upon PF Littlewood rule is very easy for us to go for that. Now, let us start this particular session with one or two simple examples, and then we will try to extend this knowledge to a multi class allocation problem also. This is the simple example which is based on our previous session, and this will give some kind of recap also of that particular class. Now, you have a particular situation where you have one airplane which is having a capacity of 150, and out of that 150 seats you have kept booking limit of 80. So, C is 150, B is 80. So, you can easily understand that protection label Y is 70 that you are keeping, and as you remember that B for full fare, BF in this case will be how much, that is 150. So, here the protection label for full fare class is 70. By this time I hope we all are very much aware what is the meaning of protection label. That means 70 seats are exclusively reserved for full fare. You see, you can book more than 70 seats also for full fare. If demand is coming, let us say for 90 seats for full fare, so you can book 90 seats also, 150 seats also for full fare. All the booking limit means all the seats which are available up to that class will always be available for higher class. But if 90 seats booking request comes for lower fare class, that cannot be executed. The meaning is, if request for 90 seats in discount class, you will reject it. This request will be rejected. But if request for 90 seats in full fare class, it is accepted. So, you see that this is the nested booking control system which we have discussed about 4-5 class ago. So, though only 70 seats are protected for Y class for full fare class, but since as per the dynamic nesting system, all the inventory which is available at that particular time will always be available for higher class. So, you are ready to give 90, 100 or any number of seats if the total seats are available in the aircraft is up to that level. Now, I am changing this aircraft in this example from 150 seats aircraft to a 100 seat aircraft. So, the situation is, earlier I was having 150 seat aircraft, now I am going to have because of some maintenance issue the 100 seats aircraft, and PDPF remains as it is. There is no change in the full fare, there is no change in the discounted fare, and there is no change in the forecast also, that for full fare, discounted fare, etcetera, etcetera. So, the question is what will be the protection labels and the discount labels, booking labels for this smaller air. So, if there is no change in full fare demand and the lower fare demand, there is no change in the forecast also. So, otherwise if you use your general knowledge etcetera, you will try to proportionately reduce the number, that 80 in 150. So, how many in 100? That will be the way you will solve your this question. But since it is a situation of revenue optimization, revenue maximization, so we will keep our protection label in this case also equivalent to 70. So, therefore, the booking limit for discounted fare will come to 30 seats. Earlier the booking limit for the discounted class was 80 seats. Now, the booking limit for the discounted class will be 30 seats. 70 seats you will still keep for your. So, 70 was the protection label earlier also, and 70 is the protection label for this new situation when other parameters are not changing, only the available capacity is changing. So, this is the simple example which I thought we should know, that how are we going to handle our changing capacity when there is no change in the fares, there is no change in the forecast also. I hope we all understood this example clearly. Now, moving further to have some other kind of examples in these two class category. The mean full fare demand for a flight with a 100 seat aircraft is 50 with a standard deviation of 100. So, mean demand is 50, standard deviation is 100. And standard deviation of demand is 100. For any fare ratio PD upon PF, the corresponding optimal booking limit is the smallest value of B for which this relationship will hold good. So, let us see how are we going to execute it. So, in this case we have created a detailed analysis of this particular situation. So, you please remember this situation, that mean demand 50, the standard deviation is 100, and now we will be changing the ratio and we will see that what is the smallest value of B for which this left hand side is just ahead of PD upon PF. So, since PD upon PF is fixed, we know that what is the discounted fare, what is the full fare. We need to determine So, you can simplify the situation. We want to determine B, so that we will call it B optimal, and this will be when 1 minus f f c minus b is just equal to or more than this ratio of P d upon P f. So, you see that fair ratio we are considering 0.4, P d upon P f, this P d upon 0.4 is P d upon P f, and for this P d upon P f equals to 0.4, the optimal booking limit is 25, and you will do this on your own when you are going to do it for 0.6, for which it is going to be 76. So, we are keeping different types of situations, and let us see that what will be the value of B and how this table is executed. So, take us the first part of the table, and then you can do these calculations on your own. Now, value of this function 1 minus f f c minus b as a function of B when the total capacity is 100 seats and the mean full demand is 50 with a standard deviation of 100. Now, in this case, if I am keeping it 0, B is 0, the value of this function 1 minus f f c minus b will be 0.309. This is the value of this function. So, I have started increasing the value of B from 0 to 1 to 5 to 10 to 15 and so on, and when I am increasing the value of these B's, we see that when I am just reaching to this B equals to 25, when I am reaching to this B equals to 25, the value of 1 minus f f c minus b is coming to be 0.401, which is just higher, than this 0.4. So, if my P d upon P f is equals to 0.4, my booking limit should be 25, and protection level correspondingly for higher class should be equals to 75. You further increase B, and you can see that we have done this calculation up to B equals to 100. Up to B equals to 100 we have done this calculation, and here you see that if booking limit is for 0.6, so you see that 0.48, 0.496, 0.5. So, for example, if my price ratio is 0.5, for example, P d is half of your full fare. So, in that case booking limit is 50. If it is 0.6, the booking limit will be 76. So, you can play, once you have this table ready with you, then you can play with any level of P d and P f, and by knowing that P d and P f, you can easily calculate the value of your booking control using this particular calculations. By changing the value of B, we are getting the corresponding value of our booking control. So, you see that we have done this calculation for B equals to 0 to B equals to 100, and we saw that for a price ratio of 0.390 and less, the booking limit will be 0. So, for a price ratio of this 309, sorry, this is a slight typo here, this is 0.309. For this price ratio, the booking limit will be 0. You will keep all your capacity for your higher fare class, and for 0.691, it is better to keep only for all your capacity again for same type of fare. So, this is a very simple and useful way of knowing that how much you are going to keep for your particular booking limit. You just need to calculate for this. So, for this you just need to calculate this particular value of the function, and for getting this value of the function you can use Excel tables, where you are using this function for calculating the value of f f c minus b, and this will be calculated using the value of mean equals to 50, standard deviation equals to 100, and accordingly all these different values are calculated, which are directly used in this particular table. We can also take another example. If you remember that in one of our earlier classes we discussed a very popular case of news vendor problem. In our inventory management, in our forecasting also, we use this news vendor problem very often whenever we have a single opportunity of deciding how much to keep with you. And this issue of optimal discount booking limit is also, you can see, very much similar to this news vendor problem, because in that news vendor problem and this booking system also you have a single opportunity. If you cannot decide properly that how many newspapers you want to keep in the morning, you will lose that opportunity of earning the profit. And same thing, if the flight has taken off, if I am considering airline example, then whatever spoilage or dilution has happened, it is happened. You cannot undo that. So, time factor is very important, and therefore, the two class problem can be very analogous to our news vendor problem. So, as I just mentioned that airline needs to determine how many seats to protect or order. Here you can see the seats which you are protecting for full fare is equivalent to the order this news vendor is doing for procuring the newspapers. So, it is very much similar to this. The airline's unit cost from protecting too many seats is a displaced discount fare. The understocking cost is the revenue from a lost full fare booking minus the discount fare. So, this is the cost of understocking, that is PF, full fare minus PD, that is cost of understocking. That we know that understocking means the profit which is possible to you, but you are deprived of the profits. And cost of over ordering, we know that you have actually procured more inventory, you are unable to sell that inventory, and therefore, this extra inventory available to you is a cost to you. So, when it is cost to you, it is equal to keeping higher protection level. When you are keeping more for your discounted fare and there is a possibility of getting more customers in the full fare, that is actually the cost of understocking. So, in this way you can simply consider that production levels should be set using this simple formula, which we have already discussed in our classes. So, you can refer those videos where we discuss this concept of news vendor problem, and using this formula of that news vendor problem, U upon U plus O, that is cost of understocking and cost of understocking plus cost of overstocking, that is our formula for deciding the protection level. And this can be translated in terms of our discussions of price for full fare and price for discounted, 1 minus PD upon PF. So, in fact, this also is very similar to, if you remember this particular thing, that is PD upon PF is actually 1 minus Fy. This is coming like that, and we remember that Fy, y is our protection label which is C minus B. This is what we are just coming from this news vendor problem. Now, go for a minute to this our previous slides, where also we kept the same idea that 1 minus f f c minus v, but that 1 minus f f c minus v is 1 minus f f y should be greater than equals to p d upon p f. So, we are developing same formula 1 minus f f c minus b, that is equals to p d upon p f. So, whether we are coming from the decision tree approach or whether we are coming from the news vendor problem approach, you will reach to the same level of calculations. So, this is another way to understanding the same concept as a news vendor problem, because we have done that in our previous classes. Now, after understanding this two class system, but generally you know in our servers we may have multiple classes, and in our earlier examples also when we understood the concept of cancellations, booking control, nested bookings also, in that also all the examples were having multiple class problems. You are having various segments of the customers, and out of those segments of the customers you are deciding a particular fare for a particular class. So, there are situations that you are not satisfied with just two classes, but you are going to have multiple classes in your system. So, again the whole idea is that you need to decide the booking limits for each of these classes, so that you maximize the total contribution. And in this particular case, when we are going for a multi-class model, the assumptions which we are going to take. So, the product has n fare classes and each with an associated fare. Fare classes are numbered in descending fare order. So, you see that the class 1, this will be the general terminology we are going to follow, and we are already following in earlier classes also. 1 is considered to be the highest fare class, 2 is second highest, third is third highest, and the n is the lowest fare class. So, P1, P2, P3 up to Pn, if n fare classes are there. So, this is highest fare and Pn is the lowest fare. So, demand in each class is an independent random variable. This is also important to note that demand in each class is independent. The meaning is that demand of one class is not getting affected because of demand of other classes. Every class has independent demand, and therefore, our solution process will become quite easy because of independence of the each classes. And each fare class is denoted by di for a fare class, that is the demand distribution, and it follows a probability distribution of f I x defined on integer x is greater than equals to 0. So, the probability distribution f I x for f I x is the probability distribution for ith class. Total n classes are there. So, I varies from 1 to n actually. So, that is the basic, you can say, nomenclature terminologies we are going to follow for this multiple class problem system. So, this f I x is the probability that demand for fare class I will be x, and f I x denotes the probability that d I is less than equals to x. Demand books in increasing fare order, like in the two class system also we see that first the lower fare class is completed and then you start for higher class. Same is going to happen here if there are n classes. So, first nth class will happen, then the n minus 1 and then the second and then the first if n is equals to 4, that is the lowest fare will be booked first. There are no shows or cancellation. So, here we are assuming for the time being that there are no case of no show or cancellation, and the objective function is to maximize the expected revenue. So, the time convention which we are going to follow for this multi-class model, if you see this particular figure, that the booking starts with x n, that is the booking starts with this x n, amount for the nth period for the lowest fare. This will continue for the time for the lowest fare class, and then it will start for n minus 1th period, and then will continue off for higher fare classes. So, it is for x n for this particular fare class which is the lowest, and it will continue for n periods. And as we are coming closer to the time of departure of the particular flight, so you have divided the time zones also, that maybe if I am starting, let us say this is the time of departure June 2024. So, if I am starting my booking, let us say in the March 2024. So, maybe up to let us say 10th of April this booking, 20th April this booking, then maybe 30th April, maybe 15th May, maybe 20th May, and maybe 1st June. That is how the time spending is happening, and the fare classes are changing. This is the lowest fare, and we, as we are coming closer to the time of departure, we are reaching to the highest fare class, and these are the number of bookings which are happening in these particular classes. So, this is the time convention for multiple class model in our discussion. Now, few more important things before we actually go for the model building. The airline's decision at the start of each period j is to how many bookings to allow for that particular class. Now, it is possible that during this particular period bookings are coming for x n bookings are coming for this low fare class, but you may have a, let us say, limit for b n. If x n is more than b n, some of the bookings will be rejected, but if x n is less than b n or equal to b n, all the bookings will be accepted. So, this will keep happening for every class, that if the requests which are coming are less than the quota which you have kept for that particular class, you are going to accept the bookings, otherwise you will reject some of the bookings, and these bookings may go to the subsequent higher fare classes if customer wishes for the same. So, this is the booking till the beginning of the period j is these, and unbooked capacity is C j minus this many. So, total capacity of your system is C, that is the total capacity, and out of the total capacity for any particular time you have booked, if I am let us say I want to know at this particular time the beginning of third period. So, all these x n minus 1, x n minus 2 up to this point, sigma of that is what is represented here, that is the sigma of that all these seats are already booked, and C minus this sigma is the unbooked capacity available at that particular time. And we will see that more demand is expected in the higher fare class. Using the power of analytics these days, we can have dynamic booking control also, that you initially decided that we are going to have B 1, B 2, B 3 kind of booking, but B 1 can also change, B 2 can also change, B 3 can also change in real time. So, that is the power of analytics, that you may not have the static quota allocation for your classes, rather it can be a dynamic allocation for your classes. Airline, we assume, is known of the demand distribution for the coming periods. Airline needs to find the maximum number of booking for class J to accept in order to maximize their expected revenue. The solution approach in this particular case, which we are going to discuss in our subsequent videos, that the airline only needs to calculate one booking limit at the start of each period, since it will receive booking only from one fare class during a period. This is very important. When you are starting a particular time, let us say I am starting this third booking period. Now, at this third booking period, how many seats I should give for this fare class P3? I need not to know for P2, P1 at this time, because at this third period I am going to accept booking only for this particular class. So, I am more interested, or I am rather only interested in knowing the booking limits for the third class, rather doing calculation for all the available classes at that time. You see, when I am going for P3 class, the Pn, Pn minus 1, Pn minus 2, etc. are already over. So, I am not going to go back into the time, I am not going into the future also. So, I am only talking of the present booking class for which I am going to do booking in this particular period. So, that makes our life slightly comfortable, that rather doing the entire calculation for all the booking classes available at a particular time, you have to do calculation only for a particular booking class for which you are going to accept booking in that particular period. So, these are some of the conventions which we are going to follow when we are going to develop a model for multi-class model, and that model we will do in our next classes. So, with this we come to end of this particular class. Thank you very much.